Well, ahoy, mateys. Happy New Year. We're jumping into 5.1 and 5.2, which is all about systems of linear equations. Now, basically, all that a system of equations is when you have two or more equations with two or more variables. And what you're trying to do is find where both variables have answers to both equations. Um, what does that mean exactly? Well, let's say you have an equation with x and y in it. You can graph it and it'll give you a straight line. And then let's say you have a second equation with x and y in it. It graphs it and gives you a second straight line. The point where those two lines intersect is a solution to both of those equations, and that is a solution to a system of equations. So basically, that's what we're going to be doing for this chapter, is solving when you have two equations and two variables. So these are some vocab things you'll need to know. This is all stuff we have talked about before, though: ordered pairs, linear equations, and so on. Let's jump into how to solve things like these. So first of all, if you have a system of equations, it's going to look something like this, where you have two different equations spelled out. So again, x plus y equals 7. There's a lot of answers, a lot of ordered pairs that'll work for that. So like 1 and 6, 5 and 2, -1 and 8. Those all add up to 7. And then you have a second equation where 2 times x minus 3 times y equals -11. Again, that would have a bunch of different possibilities for x and y that make these true. But there's only one value of x and y that work for both of these equations. That's where these two lines would intersect if you were to graph them. So if you're a note taker, you might want to jot these down. Let's jump into how to solve something like this. So let's say you have x plus y equals 7 and 2x minus 3y equals -11. And it's saying, does the ordered pair 2, 5, is that the solution to this equation? System of equations. So what you're going to do is replace x with 2 and replace y with 5 for both of these. It's got to work for both equations. So does 2, 5 work for this system of equations? Well, let's see. You substitute them in. 2 plus 5 does indeed equal 7, but does 2 times 2 minus 3 times 5 equal -11 is the other question. And it does. Look at that. So 2, 5 is the solution to this system of equations. If you were to graph these two lines, that is the point where they would intersect, is at 2, 5. All right, what about for B here? Does -2, 0 satisfy as a solution to this system of equations? All right, so if you plug in, oh, look at that. There's a lovely explanation. All right, so for B, if you substitute in -2 for x and 0 for y, you'll find out that it does work for the first equation, but it doesn't work for the second equation. So -2 plus 4 does not equal 0. Therefore, it is not a solution to this system of equations. It only works for one of the equations, not both. So that is not the point where these two lines intersect. So to solve something like this, if it doesn't give you points to plug in and try it, you don't want to guess, because that's going to take forever. So the way you're going to solve these system of equations is by graphing. That's what 5.1 is anyway. So for 5.1, graphing on Desmos works really well, or a graphing calculator if you have one, or just good old-fashioned paper and pencil. Make XY tables and graph them. So here's the steps if you like to take notes on how to do these things with steps. So step 1 is you graph each of the equations. Step 2 is you estimate the point of intersection if you can't directly see it off of a graph. And then step 3 is you check the point by plugging it in. So you look at the graph, you find out what point it looks like they intersect, plug in those values for x and y to make sure they work, and that's how you use a graph to solve these. So to solve something like this, y equals -2x plus 5, the first thing you want to do is graph y equals -2x plus 5. So the y-intercept is 5. The slope is -2, so you start at 0, 5, and then you go down 2 and over 1, down 2 and over 1, and so on. You also graph the second one. I'm just going to walk through this because I'm not going to have you graph on Edpuzzle. So you graph the first equation, which we've done. Might need a little refresher. I know it's been a whole year since we've done this. And then you graph the second one. 4x minus 1 has a y-intercept of -1 and goes up 4 every time it goes over 1. And there is the point of intersection. So looking at these graphs, what is the value that makes both of these work? So yeah, the value for x is 1 and the value for y is 3. So 1, 3 is the solution to this. And then you should, again, plug it in to make sure it works. So when x is 1, y is 3, that works for both of these. Therefore, it is the solution to the system of equations. Okay, hopefully that makes sense. Moving on. Okay, you're going to see some word problems. So again, I'm not going to have you graph on Edpuzzle, but we're going to go through how to turn something like this into a system of equations. So a roofing contractor buys 30 bundles of shingles, 4 rolls of roofing paper, and it costs $1,040 total. And then in a second purchase at the same prices, the contractor buys 8 bundles of shingles for $256 straight up. So what is an equation that represents this 30 bundles of shingles and 4 rolls of roofing paper for $1,040? All right, so hopefully you came up with something similar to this. I'm just going to go through this first example. So 30, and then you use whatever variables you want. So they're using x for bundles and y for rolls. So 30x plus 4y equals 1,040 would be that first equation. And then the second equation, they didn't buy any rolls, it's just straight up 8 bundles. So 8x equals 256. You could then graph these, and you would find out a solution to this problem. We're not going to do that because I want to jump into 5.2. So anyway, this is one way to solve it, is you graph both of them and you find out the point of intersection on a graph. 5.2, though, is to solve these algebraically, and you're going to use what's called substitution to solve these without having to make graphs, because graphs you're going to see eventually will be more of a pain than these other methods. So for 5.2, you're not going to be using graphs. You're going to be using what's called substitution. So basically how that works, again, if you're a note taker, write these down. These are your steps to substituting. So you solve one of the equations for one of the variables. So you get it so it says x equals or y equals. You will then substitute that into the second equation, and then you solve it, and that'll tell you one of the variables. That didn't probably make a ton of sense. So we're going to go through an example that will make more sense. But again, copy these down in your notes, and then you can add these examples to your notes as well. Okay, so here we have this system of equations. We have y equals negative 2x minus 9. And we have 6x minus 5y equals negative 19. Notice this is in slope-intercept form, and this is in standard form. Substitution is best used when you have slope-intercept form and standard form. Okay, so we already have this first equation solved for y. You already got y by itself. So what you're going to do is replace this y in the second equation. Let's see if it shows it nicely here. So you're going to replace this negative 2x minus 9 for y in the second equation, like so. Okay. I'm going to have you pause and take a look at that and make sure that all makes sense, because that's the key to substitution right there. Okay, so hopefully you understand that now. And then you basically can solve this because you only have one variable now. You just have x to solve for. So don't forget, you got to distribute negative 5 to make this a plus 10x and then a plus 45. If you have questions on distributing, let me know. It's very important. Then you can simplify it and get 16x plus 45, and then you can solve it and you find out that x equals negative 4. You've now solved for one of the variables, and that is true for both of these equations, but you still have to figure out what y is. How are you going to do that? Yeah, you're going to replace this x with a negative 4 in either of these equations and then solve it. In fact, you should solve it in both of these equations to make sure that it is right. So if you plug in negative 4 for x here, you solve it for y and you get y equals negative 1. Okay, you should also plug it in here and solve it and prove that y equals negative 1. So your solution is x is negative 4, y is negative 1, which you can write as an ordered pair or write it out. Okay. And again, they're showing how to check it, except they're checking it with the same. Oh, here we go. Yeah, so you should check it by plugging it into the second equation and making sure it works. And it does. So that is the solution to that system of equations. No graphing required. You just substitute one equation into the other equation. All right, let's jump into trying this one out. So on your own paper, solve this using substitution. Good luck. Okay, let's see how you did. So first, you have to decide whether you're going to solve this for x or y. It really doesn't matter. You'll still get the same answer no matter how you solve it. For me, it would be easier, like they did, to solve it for y, because you don't have to worry about negatives. So if you add x to each side, you get y equals x plus 3 for this top equation. You will then substitute that into the second equation. So you're going to replace this y with x plus 3. Hopefully that all makes sense. Make sure that makes sense. Okay, if you have any questions about that, make sure to ask me, because that is the key to substitution. And then you solve it. So when you add 3x plus x, you get 4x plus this 3, and you end up getting x equals -1. That is only half the solution. You then plug in -1 to either of these expressions or equations, and solve it to figure out what y is. And you'll find out y is 2, which again, you should check by plugging in that solution of x is -1, y is 2 into both of these to make sure they work for both equations. And they do. And here's a check of that, a very quick one. You'll see, oh yeah, it works. Fantastic. Okay, so that is substitution. So we have two ways of solving now. We have graphing, where you graph both lines and find out where they intersect. The second way is substituting. You substitute one equation in for the other equation and solve it. And there we go. And you're going to be solving problems like this, a word problem, which I'm going to go through quickly just to keep this video shorter than it could be. So we have a drama club that earns 1,040, selling 64 adult tickets and 132 student tickets. What is an expression? I'm sorry, an equation, because we have an equal sign. What is an equation that represents that? Okay, so it's 64x plus 132y equals 1,040. That would be the first equation. And then we have a second equation that says an adult ticket costs twice as much as a student ticket. So you would write that as, let me get that out of the way, x equals 2y. And then you can solve that by substituting. This is a great one to substitute because you only have to replace this x here with this 2y. And we'll just go through that quickly. There it is. So you replace this x with 2y, and you end up getting 128y plus 132y, which is 260y, equals 1,040, and then you divide to get y equals 4. So that tells you how many student tickets were sold. You then plug that in to figure out how many adult tickets were sold, which is 8. And there you go. And I lied. We know how many were sold. It's the cost per ticket is what these variables stand for. So 8 is the cost of an adult ticket. 4 is the cost of a student ticket. So you'll be solving problems like that using substitution. Okay, as you're working through these, if you have questions, let me know. If you need any help with distributing, or with graphing with any medium, let me know. Good luck, and I will see you in class. Arr!